There is a machine that cools your entire house, costs about $30 to run for a full summer, and your grandparents had one in every new home built before 1960. And then the market decided you should forget it existed. You are running a central air conditioner right now, or you will be by August, and it is costing you somewhere between 50 cents and $1 every single hour it runs. The machine I am talking about costs pennies per hour. It moves more air through your house in 4 minutes than your AC moves in an hour. It requires no refrigerant, no service contract, no annual tune-up. It was standard equipment in American homes through the 1950s and into the early 1960s, and then it disappeared from new construction almost entirely. Why did it disappear if the math is that clear? What kind of climate do you need to live in for it to actually work? And what does the $30 in the title actually mean? Because I want to be honest with you about that before we go any further. Those 3 questions are what this video answers. The machine is called a whole house ventilation fan, not a ceiling fan, not an attic fan. Those are different things and they do a different job. A whole house fan is a large, powerful fan mounted in a central ceiling, usually a hallway ceiling, with a duct venting directly up into the attic. When you open your windows and switch it on, it pulls air in from every open window in the house simultaneously and pushes that air out through the attic and out through the attic vents into the night. The numbers are not complicated. A standard central AC compressor draws around 3,500 watts. The whole house fan draws between 300 and 700 watts. At mid-2026, electricity rates, that is the difference between roughly 50 cents an hour and a few pennies an hour. Run the AC for 8 hours on a July night, and you have spent $4. Run the fan for the same 8 hours, and you have spent less than 30 cents. Across a full summer, that difference compounds. The $30 seasonal operating cost is real. I will come back to the full picture of what it actually costs to own one. Now, the physics. I want you to understand this clearly, because once you do, the rest of this falls into place on its own. Hot air rises. That is not a metaphor. It is the behavior of warm air molecules at lower density than the cool air around them. In your house on a summer afternoon, the hottest air is sitting near the ceiling of every room. Without intervention, it has nowhere to go. Your walls hold it in. Your ceiling holds it up. Your attic, which on a July afternoon reaches 140 degrees or higher, is radiating heat back down through the drywall into every room below it. Your AC is not just cooling your living room. It is fighting that 140-degree attic every hour it runs. The attic heat loads the ceiling loads the room, and the compressor runs longer and harder to overcome it. Every week on this channel, one honest fix for your home and your yard, 30 years of methods, tested by hand, nothing sold to you. If that is useful to you, subscribe, and the next one will find you. In homes where whole house fans were kept and used correctly, AC compressors tend to last longer and run less. The equipment carries a lower thermal load and simply wears out more slowly over time. The whole house fan does not cool air. What it does is flush the attic. You run it in the evening once outdoor temperatures drop, and it pulls the 140-degree attic air out through the vents and replaces it with the cooler night air coming in through your windows. By the time you go to bed, the attic is no longer a heat source. The ceiling is no longer radiating. The house is 15 to 20 degrees cooler than it was 3 hours ago, and it cost you almost nothing to get there. My grandfather, Kenji, used to leave a gap under the eaves of his workshop roof in Nagano on purpose, and he'd prop the floor panels open on hot nights to let air move through underneath. He called it letting the house breathe. I didn't understand the mechanism as a boy. I understood it perfectly the first time I ran a whole house fan in my own home decades later. The whole house fan is the mechanical version of the same idea. But if the math is this obvious, why did the fan disappear? This is the puzzle, and I want to give you an honest answer rather than a convenient one. There are 3 parts to the explanation. The first is construction. Beginning in the late 1950s and through the 1960s, American home design shifted toward tighter, more sealed building envelopes. Homes were built with AC in mind from the framing stage. A whole house fan requires a specific attic configuration and adequate ventilation area. In a house designed to be sealed, retrofitting one is structurally awkward and sometimes impractical. The second part is money. A machine that costs $30 a summer to operate generates no recurring revenue, no refrigerant to refill, no annual service visit, no filter subscription. AC system generates service contracts, refrigerant recharges, replacement parts, and eventually a full unit replacement every 15 to 20 years. The economics of the industry did not favor keeping the fan in the conversation. The third part is culture. By the late 1960s, having central air conditioning was a signal. It meant the house was modern. The whole house fan became associated with an older way of living. That association was enough to bury it in new construction even where the climate would have supported it. None of this requires a conspiracy. The fan simply lost on incentives, not on performance. The physics did not change. The machine still works exactly the way it always worked. But here is what controls whether it works for you specifically. The whole house fan is a night machine. It does not make cold air. It trades your indoor air for outdoor air. And that trade only makes sense if the outdoor air is cooler than what is inside your house. That distinction decides everything. The optimal window is when outdoor temperatures drop into the mid-60s to low 70s Fahrenheit, typically after 9 or 10 in the evening in the climates where the fan performs best. You open the windows, run the fan for 45 to 90 minutes, then seal the house before the outdoor temperature begins climbing again at dawn. The thermal mass of the walls, floors, and furnishings holds the cool through much of the following day. In those conditions, the AC either never starts or runs for a fraction of its normal hours. Drop your city in the comments and tell me whether your house ever had one of these fans or whether you still use one. I read every one. Now the climate map, and this is the part that decides whether any of this is relevant to you at all. The inland west, the mountain west, and the upper Midwest are where the fan works best. Dry heat days followed by night lows regularly in the 60s. In those regions, the fan is genuinely superior to AC for a significant portion of the cooling season. Denver, Boise, Albuquerque, Salt Lake City. Parts of the upper Great Plains. If you live there and you do not have a whole house fan, you are spending money you do not have to spend. The Pacific Coast and some Mid-South transitional areas are marginal. The fan works during mild stretches. It does not carry a full heat event. The Gulf Coast, the Deep South, Florida, and the low elevation Southeast are where the fan loses. Night lows regularly at 80 degrees or above. High humidity means that moving warm saturated air through the house does not cool the room. It makes the room feel worse. The physics cannot be argued with. Walk away. If you are in Florida, this is not your fix. Someone will say it worked for their grandmother in Pensacola in 1962. She was right for 1962. The summers are hotter now and the nights are wetter. The climate data has moved. The desert Southwest is the counterintuitive failure case. Phoenix in July. Tucson in August. The days are brutal, but the nights should cool down, and sometimes they do. But in peak summer, Phoenix nights can stay above 100 degrees. The fan fails in extreme humidity, and it fails in extreme desert heat, past a certain threshold. The wind zone does not include either edge of the map. Now, the full picture on cost, because I said I would be honest about this. The $30 is the seasonal operating cost. The unit itself ranges from around $150 for a basic model you can install yourself in a central hallway ceiling to $400 or more for larger whole house systems. Installation is a half-day job if your attic access is straightforward. Now, 6 safety points, and I will not skip them. The fan moves a large volume of air, and that air has to exit through your attic vents, soffit, gable, or ridge. If those vents are undersized for the fan's airflow rating, pressure builds in the attic, the fan underperforms, and you can force moisture into the framing over time. Check the manufacturer's net free area requirement against your existing vent area before the fan goes in. Second, this fan needs to be wired to a switch, and that means real electrical work. If you are not comfortable working with house wiring, hire a licensed electrician for that part specifically. It typically adds $100 to $200 to the job. If you do the wiring yourself, shut off the breaker to that circuit before you touch any wire and confirm it's off with a voltage tester before you proceed. This is not the place to guess. Third, do the installation work in the early morning, not midday. The attic will be far cooler then. Bring water and step only on the joists, never between them. Fourth, never run a whole house fan with the attic access hatch open. The fan will short circuit and pull conditioned air directly out rather than flushing the attic. Fifth, keep children away from the ceiling grill while the fan is running. Sixth, if your home was built before 1978, have the attic inspected for vermiculite insulation before cutting any ceiling opening. Vermiculite from that era can contain asbestos. That is not a detail to skip. The operational sequence is simple. Wait until outdoor temperature drops below indoor temperature, usually after 9 in the evening. Open windows on the windward side of the house or on multiple sides for cross ventilation. Switch on the fan, run it for 45 to 90 minutes. Seal the house before sunrise. In the wind zone, homeowners have reported cutting AC runtime by 60 to 80% across mild to moderate summer periods. And that pattern has held up consistently for decades wherever the fan is used correctly. The machine still works. That is the whole house fan you want. The question is whether anyone bothered to tell you it was an option.